Good morning. How are you? Are you still energetic? That's good. Today we will discuss another most essential competency in chemistry, and that is about molecular formula of compounds. Do not be distracted with anything around you. Just focus and be attentive. So what are the things that you are expected to learn after this lesson? This module is developed and designed for senior high school STEM students. Specifically, you are expected to define molecular formula. Determine the molecular formula of a compound given its percent composition, empirical formula, and the molar mass. And appreciate the importance of molecular formula. Let's now begin with your pretest. Be ready with your ballpen and paper. Choose the letter of the best answer. Number 1. A chemical formula that shows the actual number and kinds of atoms present in one molecule of a compound is called A. Molecular formula, B. Empirical formula, C. Chemical formula, and letter D. Ionic formula. Number 2. Epinephrine, adrenaline, is a hormone secreted into the bloodstream in times of stress. It contains 59.0% carbon, 7.15% hydrogen, 26.20% oxygen, and 7.65% nitrogen, and has a molar mass of 183 gram per mole. What is its molecular formula? A. C7H9N2O, B. C5H11N3O2, C. C9H13NO3, and letter D. C8H12NO2. Number 3. What is the molecular formula for a compound with the empirical formula K2SO4 and a molecular mass of 696 gram? A. C7H9N2O, B. C5H11N3O2, C. C9H13NO3, D. C8H12NO2. Number 4. What is the molecular formula for a compound with the empirical formula CaCl2 and a molecular mass of 330 grams? A. C7H9N2O, B. C5H11N3O2, C. C9H13NO3, D. C8H12NO2. Number 5. What is the molecular formula if the empirical formula is CH2O and the molecular mass is 180.18? A. C7H9N2O, B. C5H11N3O2, C. C9H13NO3, D. C8H12NO2. Let us now check your answers. Number 1A, 2C, 3D, 4B, 5D. Okay, count the number of correct answers. You don't need to worry if you did not get a good score. Anyway, we will discuss more about those questions as we go along with our discussion. Recall that empirical formulas are symbols representing the relative numbers of a compound's elements. Let us review your knowledge about empirical formula before we proceed with the new lesson. Answer the following problems. Determine the empirical formula of each compound from its percent composition. So number 1, 30.4% nitrogen, 69.6% oxygen. So in the table, you will identify the elements, what is its mass, atomic mass of each element, simplest ratio, empirical formula, the structure is provided with you. Answer. So you will have elements are nitrogen and oxygen, 30.4 mass of nitrogen, 69.6% for oxygen, atomic mass of nitrogen 14.0, oxygen 16.0. The simplest ratio is 2:2. Empirical formula is N2O4, and then you have the structure. Next, number 2, 17.6% sodium, 39.7% chromium, and 42.7% oxygen. Answer. Two is to 7. So the empirical formula, Na2Cr2O7.
At this point, we will be dealing with molecular formula. Let us find out how could we use the empirical formula in determining the molecular formula of compounds.
At present, chemists have screened more than 400 variety of high antiviral associated compounds in order to search for drugs to treat COVID-19 patients. When chemists synthesize a new substance, it is usually analyzed quantitatively. In this way, the percent composition of the substance can be identified. From the compound's percent composition, you had learned that it can be used to determine its empirical formula. You also learned that the empirical formula consists of the symbols of all the elements present in the compound with its correct subscripts. This time, we will now focus on the other formula, which is known as the molecular formula. Determining the absolute numbers of atoms that compose a single molecule of a covalent compound requires knowledge of both its empirical formula and its molecular mass or molar mass. The molecular formula of a compound may also be its empirical formula, or it may be a multiple of the empirical formula. So let's have an example. The molecular formula of butene is C4H8. It means that each freely existing molecule of butene contains 4 atoms of carbon and 8 atoms of hydrogen. Its empirical formula is CH2. So empirical and molecular formula of butene. Empirical formula is CH2 and the molecular formula is C2H4. Let's have sample problem. Nicotine, the responsible for the addictive nature of cigarettes, contains 74.02% carbon, 8.710% hydrogen, and 17.27% nitrogen. If 40.57 grams of nicotine contains 0.2500 mole nicotine, what is the molecular formula of nicotine? Determining the molecular formula from the provided data will require comparison of the compound's empirical formula mass to its molar mass. As the first step, Use the percent composition to derive the compound's empirical formula. Assuming a 100-gram sample of nicotine yields the following molar amounts of its elements. 74.02 gram carbon times 1 mole over 12.0 is equal to 6.163 mole carbon. 8.710 gram hydrogen times 1 mole over 1.01 is equal to 8.624 mole hydrogen. 17.27 gram nitrogen times 1 mole over 14.0 is equal to 1.
Next step is to calculate the molar